Hello everyone, this is Rishabh Mittal. In this video, I will be discussing about why cooling is important in an engine and the cooling systems which are used to cool the engine. What cooling system does in an automobile engine is it gets the engine up to optimum temperature as quickly as possible and maintains it at that temperature. It also controls the heat produced in combustion chamber so that the engine parts are not damaged and the oil does not break down. In an automobile engine, only a part of the total fuel energy supplied to the internal combustion engine is converted into useful work. The work is delivered at the crankshaft and rest of the fuel energy is rejected as follows. First of all, the heat from the engine boundaries due to radiation, convection and to a small extent conduction. Second, exhaust heat, and lastly, heat rejected to coolant. The exact proportion of the energy supplied to the engine, which is converted into useful work, is critically influenced by many physical characteristics of the engine, such as engine design, type of the fluid used, cooling system, etc. In general, about 30% of the energy supplied is converted into useful work. About 30% is lost as exhaust heat, and some energy is lost in friction, compression and direct rejection from engine. The rest of the energy, about 30%, has to be removed by the cooling system if it is not to increase the engine temperature while running. Whatever may be the exact amount of the heat carried away by the coolant be, it must be noted that it is a dead loss because not only no useful work can be obtained from it, but a part of engine power is also used to remove this heat. Therefore, it goes without saying that this heat loss must be kept minimum by the designer. Now, why cooling of an engine is necessary? The question also remains as to why cooling is required at all. The cooling of the engine is necessary for the following reasons. High engine temperatures may result in very hot exhaust valve, which in turn may give rise to pre-ignition and detonation. Also, if the cylinder head temperature is high, the volumetric efficiency and hence the power output of the engine is reduced. Thus, it is clear that some form of cooling must be provided to keep the temperature of the engine low in order to avoid the loss of volumetric efficiency and hence power, engine seizure, and to avoid danger of engine failure. Now, if we overcool the engine, what can be the disadvantages of overcooling? The engine must always be kept sufficiently hot to ensure smooth and efficient operation. At too low temperatures, starting may be difficult, and above all, the low temperature corrosion assumes a significant magnitude, that the engine life is greatly reduced. At low temperatures, the sulfurous and sulfuric acids resulting from combustion of fuel attack the cylinder barrel. The dew points of these acids vary with pressure and hence the critical temperature at which corrosion assumes significant proportions varies along the cylinder barrel. To avoid condensation of acids, the coolant temperature should be greater than 70 degrees Celsius. Thus, the cooling system should not only cool but must also keep the cylinder liner temperature above a minimum level to avoid corrosion and keep good warm up performance of the engine. Now we will be learning about the different types of cooling systems. In an automobile engine, the two types of cooling systems are used: air cooled system and the water cooled system. All the heat rejected from the engine ultimately goes to air. Nevertheless, two basic systems are used to cool the engine. These are, as I have said, air cooling system and the water cooling system. What is a water cooling system? In a water cooling system, indirect air cooling using water is used as a transfer medium. Now, what can be the applications of air cooling systems? Air cooling is usually used for small engines and for engines whose application gives extreme importance to weight, such as aircraft engines. Other areas for air-cooled engines are industrial and agricultural engines where there can be a strong objection to use of water as coolant. For air cooling, the cylinder head heat transfer is increased by fanning and air is passed over these fins to affect the cooling. For air cooling of the engine, the heat transfer area is increased by filling the cylinder and cylinder head, and air is passed over them. Since the heat is directly transferred to air, this results in a very large temperature gradient between the gases and air for heat transfer, thereby reducing the surface area. Now, I have already said air-cooled systems have metal fins on the outer perimeter of the engine. Heat is transferred from the engine through these fins into the atmosphere. Now comes the liquid cooling systems. In the liquid cooling system, a liquid is circulated around the cylinders and absorb the heat from the cylinder walls and cylinder head. Now, what is a coolant? A coolant is a mixture of antifreeze and water. Antifreeze may be ethylene glycol, it may be kerosene, denatured alcohol, sugar solution, or glycerine, etc. etc. This is the coolant. What coolant does is coolant absorbs the heat as it passes through the engine and also lubricates the water pump. Hot coolant enters the radiator in which the heat is passed on to air that is flowing through the radiator. You can see the radiator and the radiator cap. It also prevents rust and corrosion from the water jackets. Cooling system flush is recommended every 2 years in order to remove any rust or contaminants. So the coolant from the cooling systems should be renewed after every 2 years. What are water jackets? Water jackets are designed to keep engine block and cylinder head cool. Water jackets are actually between the open spaces between the outside of the cylinder and inside of the cylinder block and head. When engine is running at normal operating temperature, the coolant is forced through the water jacket in the engine block through the head gasket into the head and back to the radiator. So it forms a cycle. Cylinder head gasket sits between the short block and the cylinder head. If damaged, the coolant enters the combustion chamber and the combustion into the cooling system. It will also allow the acids to form. Now, in a cooling system, impeller type water pump is used. These are some of the water pumps which are shown in the picture. Water pump draws the coolant from the radiator through the lower radiator hose and then forces it through the water jackets back into the radiator. Water pump's gasket is placed between the water pump and the engine block to prevent leakage. If left loosed, it may be taken care of that it should not be left too loose because it might leak, and if too tightened, it might crack. If the clutch fan can be wiggled up and down, most likely the water pump needs to be replaced. Water pump is driven by the crankshaft through timing belt. Timing belt keeps the cam and crankshafts in time. Drive accessory belt runs alternator, power steering pump, AC, etc. V belt, this is the V belt shown. Serpentine belt, the diagram is shown as in the picture. Now, what is an engine fan? An engine fan draws air through the radiator at low speeds, that is traffic. Clutch fan is mounted on the water pump and is driven by the drive belt. This is the engine fan. It slips at higher speed, in turn slowing the fan speed down. It locks up at low speeds, in turn speeding up the fan RPMs. It should be able to turn when the engine is turning off. Electric fan is mounted on the radiator and is operated by battery power. Is controlled by the thermostatic switch. This is the switch as shown. It is located on the thermostat housing, block or radiator. Some modern cars have the range between 193 degrees Fahrenheit to 207 degree Fahrenheit. On AC equipped cars, we all have AC equipped cars nowadays, a second fan is mounted and it runs anytime AC is turned on. What is a radiator? A radiator is a heat exchanger that removes heat from the coolant passing through it. This is the radiator diagram shown. It may be vertical, or it may have a vertical or a horizontal core. Vehicles equipped with automatic transmission have transmission cooler built into the radiator. thermostat is placed between the cylinder head and top radiator hose. Its purpose is to close off this passage when engine is cold. You can see the diagram and the flow chart also when the thermostat is open. The temperature that the thermostat opens is called thermostat rating. If temperature is stuck open, the engine will run cool, and if the thermostat is stuck closed, the engine will overheat. It can be checked by placing in the boiling water. Higher temperature thermostats are used on the modern vehicles. Now hoses, they are specifically for individual make and model. Top radiator hose brings the coolant back to the radiator and are molded. The diagram is shown. Lower radiator hose draws the coolant into the engine from the radiator and is attached to the water pump. Sometimes a spring is inserted in order to prevent collapsing. Now the credit for the pictures, obviously we should give credit from where we have taken the pictures and the data collected. The pictures have been taken from Google search engine and how stuff works. Thank you very much. I hope you like the video.